Hi students, today we will discuss a very basic concept regarding the cross product or vector product of two vectors. As we know, two vectors, suppose A and B, two vectors are given. If we are given the angle between them, then we can find out two types of products are there. One is dot product, another one is cross product. Dot product means that is scalar product, because the result will be a scalar quantity. But cross product is also known as vector product, because the product of two vectors gives you a vector. So now we will discuss about vector products and how we are using this in physics. This is a very important concept. So see here, suppose we are having two vectors, that is A and B. So A cross B will be equal to the magnitude of A and magnitude of B and sin theta and n cap. So from this is your the magnitude and this is your direction part. So if two vectors are given the angle between them, then we can evaluate the cross product like this. So suppose we are having two vectors, suppose this is your A graphically, this is your B graphically, then the angle between them is theta, then the cross product A cross B will be this one. And simply we can write this one as AB sin theta, this will be n cap. Now it's a very important in physics how to find out the direction of the cross product of two vectors. So the rule tells that two vectors, suppose A and B, they will be in a particular plane. So their cross product will be perpendicular to the plane containing the two vectors. So suppose in this case, suppose these two vectors A and B are in xy plane, then their cross product direction, that is n cap, will be along z axis. So that we can write suppose k cap. So we know how to represent the directions. So directions can be represented in terms of your orthogonal unit vectors. So you know what are the orthogonal unit vectors? They are I cap, j cap and k cap. So I will show you. Suppose this type of things are there. Suppose this is x axis, this is y axis and this is z axis. So in this case the positive x axis is represented by I cap, positive y axis is represented by j cap and positive z axis is represented by k cap. So these three vectors are known as your orthogonal unit vectors. So in these vectors, if I do the cross product, now see how to evaluate the value of the cross product. Here suppose we are getting, suppose I cross j. So the rule tells us that if we are rotating in an anti-clockwise direction, then the next vector will be the perpendicular to the plane containing the other two vectors. You see here I cross j, so we are rotating like this. So the third vector is your k cap and it is anti-clockwise, so it will come as positive, right? I think this you understand. This is similarly, if I take j cross k, then this will come as, you know, like this. So this will come as I cap. But when we rotate in a clockwise direction, then the vector product, the direction will be along the other vector, but this will be in opposite direction. So we'll write minus. Here we'll take one example. Suppose we take k cross j. Suppose we are taking k cross j. K cross j. So now you can see k cross j, so we are moving in this direction. So this will be I, but the thing is that the direction is opposite, so this will be written as minus. So I think this is understood to you. Here I'll explain again. Suppose we are given something A. So suppose A vector is, suppose x I cap. Suppose B vector is y j cap. So what will be the Direction of the cross product. So only the direction of the cross product will be equal to your, this will be equal to your I cross j, so this will be equal to your k cap. So this is a one simple example to show how to find out the directions, that is the n cap, right, from the cross product of two vectors. Similarly, if these vectors are given, they are rectangular components in the terms of x, y, z components, then we can find out their cross product by framing a determinant. So the magnitude will be given by the determinant value, and the directions we can find out by putting the formula to find out a unit vector of a given vector. Here you see, as we know, your A cross B is equal to, A cross B equals to AB sin theta n cap. So what will be your n cap? N cap will be equal to A cross B upon the magnitude of this product. So this is the mathematical way of finding out the direction or the unit vector representing the direction of the cross product of two vectors. So this is one way how to evaluate. Another way is that if we are given, suppose the rectangular components we are given, suppose A is equal to AX I cap plus AY j cap plus AZ k cap. Similarly, if B is equal to BX I cap plus BY j cap plus BZ k cap, then the A cross B that we can evaluate by framing a determinant which will be having the components of the two vectors. Just you see here, the components of A will be written first, but before that we'll write the first line as I, J and K. The first line is we'll write I, J and K. Then the first vector is A, so the components of the A will be written here, AX, AY, AZ. Similarly, the components of B will be written as BX, BY, BZ. So by this way we can evaluate and we can find out the cross product of two vectors. So you know how to evaluate the determinant value. So you see here, first we'll move in a, suppose we are moving in first row. So first term is your I. So then this column and this row will not be considered. Only thing this and this, this and this. So this will be a square matrix. So its value will be AYBZ minus AZBY. So similarly, you can write the middle term, you know, this will come as minus. So this will be this column, this row. So we are having AXBZ minus AZBX. Similarly, for K also we can write this. So this will be AXBY minus AYBX. So this is how we evaluate the cross product of two vectors if its rectangular components are given. I think the concept is clear to you all. Now we will discuss the most common or most important derivations which are linked with this cross product or vector product in physics. So applications. So the first utility we can see here, as we know, suppose two vectors are parallel to each other. Two vectors are parallel to each other. So parallel means what? The angle between them will be 0 degree. So here the theta will be 0 degree. So we can write here A cross B will be equal to AB sin theta. So its magnitude, so this will be equal to AB sin 0 degree is 0. So this will come as 0. So here we can conclude that if two vectors are parallel to each other, then their cross product or vector product will be 0. So here I will tell you a shortcut method. Suppose most time the questions asked, suppose a vector A is given as 5 I cap plus 2 j cap, suppose minus 3 k cap. So B vector is given like suppose minus 10 I cap, suppose minus m j cap plus 6 k cap. So in the question it will be asked, find out the value of m if these two vectors are parallel to each other. So then what we'll do? We'll find out the magnitude of A cross B. This should be 0. So if you calculate, finally you will find the value of m as your, this will be, the value will come as 4. The value of m will be equal to 4. Now I think it is understood to you. You have to calculate. So there is a shortcut method. Shortcut method is that the ratio, parallel means what? For the two lines, if they are parallel, then what happens? A1 by B1 is equal to A1 by B1 is equal to A2 by B2 is equal to C1 by C2. But here the sign will be changing. Understood? So by looking at this question, you can say the increment is twice. So twice and the sign is changing. So here this is plus 2. So m will be here. Suppose here it is given minus m. So that is 2. So this here this will come as 4. Right? So m value will be 4. So this is a shortcut method. Otherwise you can find out by using this formula. So this is a very important. In physics, how it is related? I can give you 2-3 examples. Suppose first thing we are getting, suppose a charged body is moving in a magnetic field. So what is the force experienced by a charged body when it is moving in an electric field or magnetic field? In an electric field, the charge is there, so force is Q into E. So there is no cross product. But when the charge is moving in a magnetic field, it will experience a force, and this is given by F is equal to your Q V cross B. That is the velocity and the magnetic field directions. So here, in many cases, some tricky questions asked. Suppose a charged particle is entering perpendicular to the magnetic field. So we can say theta is equal to 90 degree. So VBQ, VB sin theta, sin 90. So the force will be maximum if that is moving 90 degree. So this is your QVB. So in this case, force is maximum when theta is 90 degree. Theta 90 degree means what? Velocity is perpendicular to magnetic field. Similarly, if we are getting that the charged particle is moving parallel to the magnetic field. Charged particle is moving parallel to the magnetic field. Here we can find out your F will be minimum because this will be Q B cross B. So that is VB sin 0 degree. So sin 0 degree is 0. So this force will be 0. So we can say if a charged particle is entering a magnetic field parallel to the direction of the magnetic field, then the force experienced by the charge is 0. So this is the very important question. Similarly, suppose in this case the velocity will be given like I cap. The direction of the magnetic field will be given in terms of j cap. So we can use these orthogonal vectors, unit vectors, what I have written you already explained. Suppose I cross j. So I cross j will be k cap. So similarly, you can also find out the direction of the force which is acting on a charged particle. Right? The second application that we can discuss from that is we can find out the area of a triangle. Area of a triangle. How we can get area of a triangle? Now area will be equal to half the adjacent sides their cross. That is A cross B. Right? Adjacent sides. If this is area of a triangle. If we are given area of a parallelogram, area of a parallelogram, area of a parallelogram, area of a parallelogram. So what we will get? This will be equal to your adjacent sides cross product, or this will be half into the cross product of the diagonals, cross product of the diagonals, right? So these are the applications of cross product of two vectors which are mostly used in physics. I think it is understood to you all. So thank you.